Hi, I'm Mr. Kangas, and today we're going to be talking about Chapter 2, Section 2, adding integers. In the previous video, we talked about adding two numbers that are positive and two numbers that are negative. So in other words, we talked about adding equations that have the same signs, adding numbers with the same signs. In this video, we're going to talk about adding numbers with different signs. Now, when you have same signs, the rules were to add the two numbers together and keep their signs. When you have different signs, it functions differently. So, for example, if I have a negative plus a positive, or a positive plus a negative, okay? Different signs, one of each, okay? The rules for different signs are that you first off subtract the smaller number from the bigger number, and secondly you're going to keep the sign of the bigger number. Always keep the sign of the bigger number. We'll discuss why this works in just a second. Real quick, I'm just going to put the answers for these two problems up here. If you have negative 3 plus positive 5, you get an answer of positive 2. If you have positive 3 plus negative 5, you get an answer of negative 2. So where do these rules come from? Why do they work? The best way to explain that is to take a look at the number line. Alright. So we have negative 5, we have positive 5, and 4, 3, 2, 1, 0 in the middle. Okay, and then we have 2 here, and we have negative 2 here. I'm not writing in all the numbers because we're not going to use all of the numbers. So, when you are looking at a problem with two different signs, we're still adding here, so the rule, the commutative property still applies. We can do it in any order we want. So I can start with either the 3's or the 5's, doesn't matter. I always start with the bigger number. It's a great way to show why we subtract the numbers. If you start with positive 5 and you add negative 3 to it, remember when we add a negative it moves us to the left. Okay, so we're adding negative 3, so it's going to move us left 3 spaces to positive 2. And if we take a look at the other problem, we're going to start with negative 5 and we're going to add positive 3. Remember, a positive number moves to the right on the number line. So we start at negative 5 and we move right 3 spaces to negative 2. So as you can see, in both problems we went from 5 to 2. 5 to 2. Okay, just on this side, the 5 and the 2 were negative. So in both situations, it comes across a lot like subtraction. Even though technically in this problem, we're getting bigger, we're increasing, it looks like subtraction. So if you subtract the absolute value of the two numbers, of negative 3 and 5, so if you just do 5 minus 3 and get 2, and then you go to the second step, which is you keep the sign of the bigger number. Okay? So in this case, the bigger number was positive, so we kept our answer positive. And again, down here we had a 5 and we had a 3. The 5 was negative, but again, we're not worried about the signs. We're just going to do 5 minus 3 and get 2. And then we're going to say, okay, which one is bigger, the positive or the negative? In this case, the negative was bigger, so our answer is negative. Why is your answer always the same sign as the bigger number? Well, one way to think about it is that the little number is running away from the bigger number. But the little number can only move 3 spaces in this case. So right now, that 3 is 5 spaces away from 0. And the 3 is a positive number. It wants to get back to the positive side of the number line. Problem is it's too far away. It can't make it. The furthest it can go is -2. The bigger number is almost, a way to think about it, it's almost like it's absorbing the smaller number. Now the smaller number isn't going to overtake the bigger number because the bigger number is bigger. So when the bigger number absorbs the smaller number, the bigger number will change, but it will still keep its sign. So it's impossible for this little number to ever get back to the other side and change the sign of the answer. It's the same thing with the problem up here. The 5 was the bigger number. It was a number further from 0, we should say, to be more accurate. The 5 was further from 0, so the -3 could never get back to the negative side. Because in order to get back to the negative side, that -3 would have to move at least 5 spaces, but it can only move 3. So again, it's the reason why we keep the sign of the bigger number, it's because the bigger number absorbs the smaller number. And the smaller number can't get back to the other side of 0 to change the sign of the answer. It just doesn't, it's too far away from 0. It's kind of like saying we're 5 miles from 0 and we head 3 miles back towards 0. Well, you're not going to get back towards or across 0 that way. You're not moving far enough. So again, if you take a look at the number line, it doesn't matter which problem you do, -3 plus +5 or +3 plus -5. Either case, it looks like subtraction, which is why we subtract the numbers. Okay, we're going from a 5 to a 2 in either case. Just over here, the 5 and the 2 are negative. So that's all I have on adding integers for today. In the next video, we'll be talking about Chapter 2, Section 3. And we'll be working with subtracting integers, which actually ends up coming back to adding integers. We're going to use something called KFC, and we're actually not even going to use the subtraction. We're going to do something to our problems to make them into addition problems. So it'll be kind of neat. So tune in for Chapter 2, Section 3, Subtracting Integers.